Our first session is with Michael Bell, who is the Corporate Vice President and General Manager of the New Devices Group for Intel Corporation, and Scott Miller, who's the CEO and co-founder of Dragon Innovation. We could spread these out a little bit, but I think we have to stay within that black line there, so for camera purposes. Let me tell you a little bit about Michael. Michael leads a global team chartered with developing new products and technologies at Intel. He's also general manager of the New Devices Group for Intel. And he has a background that goes back to Palm and Apple, and quite interesting. And he's going to give us more details, show us more things.
I think I've dropped the clicker.
You dropped the clicker. Well, we'll find the clicker. Okay, here we go. There we are.
Thank you.
And Scott Miller is a CEO and co-founder of Dragon Innovations. And Scott gave a great workshop yesterday on design for manufacturing. And that went pretty well, did it?
That was a lot of fun.
Yeah, a lot of good questions, a lot of people there. And Scott's company helps makers and others take a product from an idea and develop it into the market, figure out how to access, how to source components, how to plan and build things. And Scott's background, he was responsible for leading the technical team at Roomba. And but I love this phrase from it. Over the course of his career, he's worked on high-efficiency robotic tuna fish, life-size robotic dinosaurs for Disney, and robotic baby dolls for Hasbro. So there's a theme there. So we are going to learn a little bit. Last year at Maker Faire Rome, and how many of you were there? A couple of you, yeah. We had Intel unveil their relationship with the maker community, particularly with the Arduino team, and announce the Galileo product. And so Michael's going to talk a little bit about that. But tell us a bit basically what Galileo is and where it fits kind of in the ecosystem.
Sure, yeah. So our new CEO took over back in June of last year, and this is a personal passion for him. I mean, he's been building things with his family, and he's anxious to show them. I'm sure he'll be showing them on Saturday when he's here. And many of us in Intel have been making stuff for years, so it just seemed natural that we would build a product that would let people innovate based on our stuff because we wanted to use it ourselves. So we produced this board based on an Intel chip, and we worked with the Arduino folks to make it fully compatible. And we announced that we were donating a bunch of them to colleges to really help spur hands-on engineering work.
Yeah, 50,000.
Yeah, and we should be on track to deliver the rest of those this year, essentially. We started last year, and we're going to be switching over to a new version of the board that I can talk about in a second for the rest of the boards we're delivering. And it's been really well received. We're even using it internally in our factories to look at process yield and things like that. And air quality monitors.
Yeah, cool. Brian talked a bit about that. He was kind of excited about some of those applications. But this is somewhere between Arduino and Raspberry Pi, right?
Well, yeah, it's, we thought we'd do the best of both worlds. Something like a Raspberry Pi, you really have to get into the guts of Linux to do anything with it, which is fine. But frankly, it's intimidating to people who, just want to make some, it's all about what they make, not how they make it. So what we wanted to do is the Arduino development environment is fantastic. And we thought we would exploit the power of that and make a really easy to use but very powerful board.
Mm-hmm. So that was really in October last year. The board came out roughly when?
We did it, actually a lot of the team is here today. I'm going to embarrass them. They're sitting over at in the Intel table. We did the board in about 60 days. It was kind of a crash effort to get it out there.
Yeah. And so we're coming up on a new generation of the board. What's new?
Yeah, so we got a lot of feedback from the community, as you can imagine. Some kind of crazy suggestions, but some really good ones. And there's a big picture of it up there. We're this summer, early this summer in June, we're going to be releasing the second version of our board, and it'll be easier to see the picture up there. But looks a lot like the first one, but we had some feedback. Higher resolution PWM control, more GPIOs, much faster GPIOs. Standard Ethernet connect or standard USB connector, standard serial connector, TTL level serial connector. So we took a lot of the feedback from the community to make the board, even better than it was.
Yeah. And that has to be kind of one of the things that's new about this at Intel is sort of interacting with they're not quite the same as interacting with customers. It's a little bit different, isn't it?
Well, it's definitely customers.
Yeah.
It's non-traditional Intel customers, but
Right.
it's a lot more fun actually. For me, it's a lot more fun talking to the people who use the stuff directly.
Yeah.
So it's been great.
Yeah. Scott, in talking to a lot of makers, one of the things I realize about something like Arduino or things like Galileo come along is these are become standardized components for projects, and it allows people who could have probably maybe a custom board or something else, it allows them to share a lot of knowledge across different projects. And similarly, when you're working with folks, that must matter as well.
Oh, it's incredibly important. I know back in the days when we were doing the Roomba, we launched in 2002, we were literally at the bare metal level, putting our transistors down and try to figure out flyback diodes and all of this. And today, if you think of it, that's sort of like with rocks banging away at this stuff. And now we just have amazing tools like these products that can let you focus on solving really interesting high-level projects and not worrying about being in the mud. And you can just go so much faster. So it's
kind of analogous to having a software stack in ways of saying these things have been established, and you can build on top of it. I mean, the air quality monitor is sort of another good example of, again, not just people creating products for a market, but solving problems, say, within a factory.
Well, it is, and I got to mention, the air quality monitor is cool because the team came to us and said, we want to deploy these in this big city, but we have no way to plug them in. Could you make your next board PoE compatible? So I went to the team and they said, let me think about that. And you take a standard little PoE thing and solder it to the bottom and you have a PoE board. So the community is really helping us define this stuff and create something that's useful to make real products out of.
Yeah, and I'm kind of just fascinated, what are these applications? And once you have these new components, you see kind of an ecosystem grow up of different applications. Well, let's go on to this Edison board, which I've been really fascinated by. I was in Maker Faire Shenzhen. Randy, member of your team, gave a presentation on it, and Mike, tell us about the Edison board.
Sure. Yeah. Perfect timing. I happen to have one here. Imagine that. Actually, I've put it up there because it actually is small enough where if I held it up, you really couldn't see it from where you guys are. The idea behind Edison was to take the concept behind Galileo and extend it. So we know there are a lot of people out there who want to build things that are smart and connected, but they don't want to have to go, to the bare metal to go figure out how to wire the chip to the radio and worry about what the radio path is and the antenna and, does it have the right layout. They want to actually take and, build their product. They don't want to have to worry about the lowest level piece. So we essentially created, it's a dual core computer using the fastest chip we put in our fastest tablets today, along with Bluetooth, LE, and Wi-Fi. And the concept here is that very quickly you can take and build a prototype based on this, without having to worry about going and getting a board created, and you can go into production. The idea is we'll build millions, so then you can actually take this and use our economies of scale to get your product out the door without having to go develop a custom board where for small product runs, the development cost of the board is really prohibitive in a lot of cases.
Mm-hmm. And Scott, what do you think of this?
I get super excited by this. So we're in the business of helping companies go from a prototype to high volume production, and just being able to start out even earlier with a device that makes that transition easy would just save us so much time and make it much more efficient for the maker and the entrepreneur to spend their time and resources thinking about scaling the product and getting the business bigger, rather than having to redo everything. Once they've proven out the prototype, start over again and go up. So this is awesome.
Cool.
Yeah, and you announced it at CES, and there are a few subtle changes since then, right?
Well, we've done two things. We originally were going to build the board in the exact shape of an SD card. And again, we went out to the community and said, what do you think? And they said, well, we love it, but, and the list of but was really, really, really long, including people want to build drones out of it. They want to run high-end printers. They want to do other things. And they wanted more horsepower, and they wanted more GPIOs. So essentially we said, well, okay, we still have that other board we did. We'll put that on the back burner for now, and we'll fast track this faster version. And as we get it out there and get feedback, if people still want the slightly slower, smaller version, we'll bring that out too. So we still have that one, but we decided to fast track this instead. Yeah.
When will it be available?
This summer.
And how will you distribute it?
We have standard distribution, kind of like the Galileo board. We're looking for, I have challenged the team to look for some creative ways, and they're going to be over there throwing stuff at me. But as a big company, it's challenging for us to figure out how to sell one or two direct from our own company. So we look at our distribution partners as a way to get that out there to people.
Right. Now I know Michael McCool's over there. He's giving a talk later on, and in our panel, or he was over there, maybe moved. There he is, there's Michael. I've seen some of the applications that he and his team have talked about. One was a notebook where you're writing in a notebook and it's kind of keeping track of that and sending it up to the cloud. Can you talk about some of the applications internally or things that you guys have done just to experiment with it?
Not really.
Not really?
What I'll say, so there's a team that's been working with both internal and external people to come up with some cool examples of this, and we'll probably be showing them at the next Maker Fair, as a matter of fact. Right. What I'll say is that it turns out there are a lot, when you have not only the hardware, but one of the things I should mention is along with this hardware, the software team has created this really easy to use, complete infrastructure for sending data from this to the cloud and doing analysis. So within like 5 minutes of plugging this in, you could have a device sending data to a cloud and looking at the data on a web portal. So you instantly get a web connected device with the ability to do analysis of the data kind of out of the box. So you can imagine, there are a lot of people who want to build something that gets data, sends it up, puts it in a nice to look at form, and this is tailor-made for that.
Yeah, Scott, I mean, we see tons of things like that on Kickstarter, right? And other devices, and to some degree they're having to build their own specialized board or other to do that, aren't they?
Yes, so just having a standardized board with a huge community around it where you can share ideas would be super helpful.
Right. So it can enable a lot of these kind of Internet of Things applications and
absolutely
obvious stuff like that. Now there's an expansion board for Edison. You want to tell us what that is?
Yeah, so we didn't want to forget the Maker community or the Arduino community because people have done amazing things. The whole point for me with the Arduino stuff is it lets you easily do something really cool. It's not about the worrying about the lower level esoterica. So what we've done is we're going to be let's see, I think I have a picture. Yeah. So what we're actually doing is we've built basically an Arduino board, compatible I/O board, and you take one of these Edison modules, and if my fingers don't fail me this morning, there's a connector on here that you snap it into, and I'm hoping this is the world's fastest Arduino board. Dual core, very high-end processing. At the same time, it'll run your sketches. It has all the I/O ports. So it's basically it turns the Edison into a very high-end Arduino for people who want to use that development environment, which again, I think is fantastic. I've actually had a little Arduino setup running on my desk since the Maker Faire back in Rome, and it's a really cool way to do stuff.
Yeah, okay, that's terrific. And then I think one of the ways that Intel's looking at sort of popularizing some of this is you have a Make It Wearable challenge, and we just kind of finished the first version of that, and it's going on. Do you want to tell us about that?
Yeah, so there's been I'll say a lot written in the press about wearables, and it's going to be the next big thing, and there'll be 100 billion or 50 billion connected devices, and we think that in order to make that hype become reality, we need to help push. So what we're doing is we've created this Make It Wearable challenge, and the idea is we finished the first sort of round. The second round's beginning now. At the end of this, there'll be awards. I think the first place participant gets $500,000. But the really interesting thing is we're taking people who've submitted great ideas, and if you become a finalist, we pair you with experts in the field of the device or the concept you're building. So you get access to expertise to help you finalize your product that you probably couldn't get. So the money's fantastic, but it's also the mentoring and the coaching that we think will help make these products really great.
Yeah. Now, one of the things that's fascinating to me about Intel is, in talking to your CEO, was just realizing that you weren't just developing products for a potential maker community and other things. That he said, we have a maker community inside of Intel, and it isn't just in Santa Clara. It is really
worldwide.
Around the world. You talk about that. I mean, you must be, to some degree, trying to organize some of those people inside of the company.
Yeah, it's funny. So we have internal maker fairs, mini little maker fairs at lunch in the various cafeterias. We are in, I won't say every country on earth, but a lot of them. And in every place we have people who have taken the Galileo boards and before that the other Arduino boards and built something cool. We have an internal mailing list of people using Galileos, and as I said, we get feedback. Trust me, our internal people give me some of the most, how do I say, direct feedback about what they like and don't like. We don't have a shy group of people at Intel. And we've really helped, some of the work we've done to refine the board has come from these internal people who have done some really amazingly cool things and said, but if I just had this feature, I could make it even better. So we've taken incorporated a lot of that into the new board. Okay. And like I said, I mean, even we're using Galileo in our own factories to improve yield. And you can imagine a little bit of a yield improvement is worth huge money to us. So this is, it's an amazingly cool maker thing that can have real dramatic impact on a business.
Right. And Scott, the other side of it is, as working with startups and other things, it's pretty amazing to have access to some of the resources that an Intel provides.
Yes, absolutely. I mean, one of the challenges with a startup is we don't have a lot of time or money, but we can really iterate quickly and fail quickly and then ultimately succeed. So having access to just the massive R&D to be able to get better and better tools and then use those to solve whatever problem we're solving is just a really interesting connection. So we're psyched about that.
Cool. Very good. We have a few minutes. Let's see if we have any questions from the audience. Anybody have any thoughts or questions about Edison, Galileo, Dragon Innovation? Yes, sir.
Just curious, what would you say is the best product you've seen using both of those boards?
Well, let me repeat the question. What would you say is the best product you've seen using either of those boards? Well, Edison really isn't out yet to...
Yeah, Edison isn't out. We actually have a team that's working with some third parties to develop things based on Edison that we can showcase this summer. And I've seen some pretty cool stuff. We're not talking about it here, but it's pretty amazing what people have done with it. In terms of Galileo, I won't say product, but what some of the even high school kids have done with this is pretty amazing. Someone sent me a picture. There was a educational challenge in Germany about 2 months ago, I think it was, and one of the people that won, it was I think it was a girl who was in 9th grade or 10th grade. I think she won, I'm not positive, but I got this great picture of her showing Angela Merkel, how her Galileo-based plant waterer, I forget exactly what it was, but it's really cool seeing, that's the reason, frankly, the reason we did Galileo up front. I had a chance to go give the commencement address at the university I went to back in Philadelphia, and I found there wasn't enough hands-on work being done. So we did the board really as a way to provide educational institutions with a way for kids to actually make stuff instead of just reading about it. So seeing high school kids doing cool stuff and showing the Chancellor of Germany how to do something is pretty cool.
Yeah. Another question? Anybody? Okay. So tell me where can we get more information about Edison and the Make It Wearable Challenge and things like that? We will have a group out in the hallway here. Okay. After the presentation. I encourage people to go find the people you can usually pick the Intel people out in the crowd in a good way. I
don't know about that. I'm joking, Intel folks.
But they are over there. No.
But if you go to the Intel website, we have information about Galileo, about the Make It Wearable Challenge, as well as later on this summer we'll have more information about Edison as we announce more details.
Yeah. Okay. Great. Well, I think one of the great things is there are real people here from Intel that you can interact with and ask questions, and I think the Edison is really fascinating. I really want to see what the maker community does with it, and we want to cover it in the magazine and do a lot of things. I think it's a really interesting enabler. Yes, sir.
Could you speculate a little further into the business about how much that Edison board might shrink if we do wearable kinds of things?
So the question was, can you speculate in the future about how the Edison board might shrink even smaller?
Yeah, it depends on. We have thoughts to do a range of these kind of devices you can imagine. We have very, very small 3mm by 3mm package parts with lower performance we could build on. I'll be honest with you, the size of the board, by and large, is dictated by the size of the memories, the flash and the DRAM we have on there, more so than our chipsets. For this Edison board, what we tried to do was build something that had enough of both to do something real with it, to build something that really could do cloud connectivity and store data. If you were to do a wearable specific board with less power and less storage requirements, it could probably be, a third that size. But, like I said, this was really, we tried to hit the sweet spot of, we wanted to be able to have people build drones, printers, as well as, smart shirts, smart football helmets. I mean, you can think of a lot of things you can do with radio connectivity, automated cloud services, and good processing power. So what we want to do is get it out there, get feedback from people, and then help figure out the next device that we build based on real feedback.
Okay. Well, I want to thank you, Michael and Scott, for sharing ideas about this, and we'll keep following as it develops, and thanks for being here at MakerCon.
Cool.
Okay.
Thanks.
Thank you, everybody.
Thanks a lot.
Good.